your quiz is tomorrow, and it's shorter than this, okay? But let's go over, we had 3 days of new lessons, Monday, Tuesday, Wednesday, so 3 different things basically on here. So the first 1 through 8 is just rewriting these problems in their other form, okay? Yeah. So I always start with the base, whatever the base is. So my base is 9, and I do it to the power on the other side. Remember the 2 on the other side of the equal sign, he's a loner. He likes to be by himself, so we put him up in the air. And then whatever's left over goes on the other side of the equal sign. And that's it. There's no work to show or anything. It's literally just being able to put that in the right order. Okay? Stay with me, though. I know you're really excited about these, but stay with me or you're going to miss how to do other problems. Okay? So down at number 5, go to number 5 with me, guys. If I'm going to write this in log form, it's going the other direction. Okay? Write it in log form. So if you're going to write something in log form, you start by writing the word log. That's the first thing you do. Write the word log. And just like we started with the base up here, 9 was the base, what would the base be in this problem? 14. So that, and guys, make sure on the quiz, I can tell that you meant to make it a subscript. I'm not getting out a ruler and measuring it, but it should be lower and smaller. Okay? Just give her a second. She's just warming up. She took a little break. My planning is right before this, so she doesn't have to work so hard. All right, leave a space. Remember, that loner up in the sky gets his own side on the other side of the equal sign, and then that 196 goes right in there. The order of the numbers matters. You can't mix them up. They have to be in that order. Okay? So you're going to have a few of those 2 types. Then, evaluate. Guys, during the quiz, you can't say to me, what does evaluate mean? Is that when I do this? You have to know that, okay? So I'm very generous with you by doing a review that matches the quiz. It's up to you to study, do the work, get the questions answered today, okay? All right, so evaluate. Whenever you see that, you want to remember to put equals X. You have to remember to put it there. It's not going to be there. And then we do exactly what we did in number 1. Rewrite this log in exponential form. Exactly like you did in problem 1. So you start with your base. It's a base of 3 to the power of X equals 1 over 27. 3 to the X equals 1 over 27. Then you're solving. Now this is exactly what you had to do on the last test. It just started with the problem looking like that. The only extra part is writing it in that form. And so what we're looking for is making like bases. So if you remember, we don't like doing the fractions, but we can handle it. Look at the 3, pretend it's just a 27, not a 1 over 27. What number do you think we can make both 3 and 27 be a base of? What number? 3, yeah. So I'm not going to do anything to this side. And on this side, I can pick up my calculator if I need to. That would be, I got it. 3 to the 3rd power in the denominator. Okay? Careful. Nope. Because are the bases the same right now? The answer is no. They're not. This side's a base 3. What's the base on this side? 1/3. We need to bring this up to the top. Okay? We're allowed to do that. Except one thing has to happen. What has to happen? The exponent sign changes. Yes. Bases are the same. Now the exponents are the same. So the answer is -3. Guys, you should be able to plug your answer back in and check it. If you put in your calculator 3 to the -3 power and hit enter, it's going to give you a decimal. But then if you hit math, enter, enter, it'll say 127. So you can easily check these. All right? let me do one graphing one with you. This is what we learned yesterday. So this is the most recent stuff. So guys, just stay with me and then you'll have the rest of the period to go back and do those. But let's make sure we remember how to do what we learned yesterday. If I come around and help and you haven't done the ones I did with you, then I'm going to tell you to watch the video before I help you. Okay? So what we're going to do is make an XY chart up to the X only. And we're going to rewrite this in its other form. So it's 6 to the Y equals X. Remember we saw this yesterday where the exponent was a Y? And we always use negative 2 to 2, but we're going to plug in for Y. So I pick up my calculator and I do 6 to the negative 2. And remember, it doesn't matter to me whether you put 0.03 or 1/36. Either one, a decimal or a fraction, is perfectly fine. Doesn't matter. But I will share with you that you'll get all of these answers. So I just plug and chug through my calculator. Now remember, that's just the parent function. So I'm going to put them on my graph with x's and not connect them. Then we'll talk about what those other numbers do. Okay? So to the right, I mean, these graphs are really small. Do the best you can. To the right one, down negative 2. So it's like right there. To the right a little bit more, down 1, 1, 0. Then they spread out. 1, 2, 3, 4, 5, 6, 1. And then remember, you don't need to go off your piece of paper to graph 36, 2. Just find a spot that looks good, and I shouldn't have put my XY chart there. I should have put it over there. But that point right there is 36, 2. So just tell me, you know that you didn't really draw it over there, but you know that that point is supposed to be it. So you can see that parent function is getting really, really close to that vertical asymptote of 0. But that's not our final answer, so let's not do any of that yet. This -1 and this -1, which direction is this one going to take our graph? Right. Right one. Yep. Right one, and then this would be down one. And what will my vertical asymptote be? X equals 1. Remember VAX. Vertical, it's a vertical line, vertical asymptote, VA. X equals whatever the number is. Okay, so I'm going to just put it on there because it just helps when my graphs are this small. So I'm just going to take each point, go right one, down one. Right one, down one, and so on.
How is that?
Because it's the opposite here. Remember how this -1 takes us to the right one? That shifts all your points, including your asymptote, to the right one. So one of the things we learned yesterday, if you remember, is when I did the parent function, it was x minus h plus k. This is always opposite. So if you see a minus, it's actually to the right. If you see a positive, it's to the left. Does that ring a bell, Harold? Maybe pull out yesterday's notes if you need to. And that's it. Okay? So that's the whole, that's how we do all 4 of those. Mm-hmm. What direction did you move all your points? Mm-hmm. You started at 0. Where did you move your asymptote to? To the right one. That's positive 1. Okay? It's always opposite. Okay, what number is my base, Dylan? Who asked me to do this? Was it you, Dylan? 19. Start with that. What's the power going to be on the 19? Follow the same exact pattern. Yep. Mm-hmm. You're not picking up your calculator at all. None of the numbers change in 1 through 8. It's literally just putting them in the correct order. Okay, I'm going to come around and help you. Who said that? I'll come over and help you. Yeah, you can go. Guys, remember, let's cut down on the hall passes, though. I know. Look, same. See? So you didn't do anything wrong. Just spot your point. We did 11 together. No, we didn't. -2. Here, let me do you guys a favor. I'll put this on Canvas right now. That way you can pull it up on your phones if you want to. Or you can take a picture of it, of course, too. Whatever works. You're funny.